Welcome to our webinar on the Northern Ireland Water Classification Statistics Report 2024. The presentation will be split into various parts. At first, I will give a summary of the value of water, then explain the structure of the statistics report to you, touch on the classification methodology, highlight the differences between the results from the Water Environment Water Framework Directive regulations and the Marine Strategy regulations. And then I start presenting the key statistics for our transitional and coastal water bodies, lakes and rivers. At the end, I briefly touch upon the available data map views and what you could do to contribute to making our water environment better. Let's start with the value of water. Water underpins everything. Humans and nature require it for life and their survival. Water quality and quantity contributes to the Northern Ireland economy, hence its protection and improvement is critical. One of the economy sectors that depends on water is tourism. Tourists would like to see a clean, healthy and attractive environment. Our water environment contributes to that. The agri-food sector is a big part of NIPSC. It generates almost £5 billion of added value, including things like dairy and meat production, beverage manufacturing, for example spirits, beers and soft drinks. The horticulture sector also requires water for washing produce and sometimes irrigation. The next sector is navigating and boating. It requires sufficient water volumes to operate locks. Households depend on clean water for drinking water, cleaning, cooking and personal hygiene. Recreation includes outdoor activities like canoeing, sailing, stand-up paddleboarding and open water swimming, to name a few. Flood prevention includes soft engineering solutions that slow down the flow and retain water in the catchment. The example in the photo shows the rain garden at Clandeboy Primary School in Bangor. I will now outline the structure of the statistics report. The report has 5 chapters plus 3 annexes. Chapter 1 explains the key facts. Chapter 2 describes the river basin districts in Northern Ireland, how classification works, and gives information on UPBT substances, so-called forever chemicals. Chapters 3, 4 and 5 present the classification for rivers, lakes and coastal and transitional water bodies. Both ecological status and chemical status is presented. Please note that the groundwater status for 2021 remains valid, as due to the slower flow and transport processes, it is not updated mid-cycle. Overall surface water body status is presented in the annexes, as it has become less meaningful since UPBT substances have been included in the assessment. Further information can be found in the Frequently Asked Questions document. I will now explain how classification status is derived. Northern Ireland is split into 3 river basin districts. 2 of them, Northwest and Naban, are international river basin districts, which are shared with the Republic of Ireland. Please note that a tiny part of the Shannon River Basin district is also in Northern Ireland, but it's so small you can't see it on the map. The Shannon River Basin district is entirely managed by the Republic of Ireland. The statistics report presents ecological status and chemical status for our surface water bodies. Ecological status is made up of several elements. These are biological quality elements, general chemical and physiochemical quality elements, specific pollutants, hydromorphological quality elements. The lowest of these elements goes forward using the one-out, all-out principle, resulting in ecological status. Ecological status is represented in 5 groups ranging from high over good to moderate, poor, and bad. As the regulations have the aim to achieve good status, the results are often summarized as good or better status and less than good status. I will concentrate on how many water bodies achieve good or better ecological status. Chemical status is presented in 3 subgroups to show the impact of new substances like cypermethrin and UPPT substances better. Subgroup A shows the chemical classification excluding both UPPT substances and cypermethrin. Subgroup B shows the chemical classification excluding UPPT substances but including cypermethrin failures. Subgroup C includes both UPPT substances and cypermethrin. Where the forever chemicals were monitored, they failed in those water bodies, and based on our technical and scientific understanding, these failures were then extrapolated to all surface water bodies. Subgroup C determines the overall chemical status, which means that based on the extrapolation of the UPPT failures, all surface water bodies fail to achieve good chemical status. The chemical status is presented in 2 groups, good and failing to achieve good. I will now briefly describe the differences in the results between water framework and marine strategy assessments. This screen shows a comparison between the assessments for water framework and marine strategy. As you can see from the maps, there's a big difference in the area assessed for water framework and marine strategy. Water framework assesses our transitional and coastal water bodies out to 1 nautical mile, and the average water body is 54 square kilometers. Marine strategy considers the coastal water bodies, but not the transitional water bodies, as well as the seabed and subsoils. The size of the Celtic Sea, outlined here with the turquoise line, is over 600,000 square kilometers, roughly 11 times bigger than the average transitional and coastal water body. More detail can be found in our Frequently Asked Questions document on our webpage. Once again, I have split my slide into 2 parts, for the water framework assessment on the left-hand side and the marine strategy assessment on the right-hand side. Surface water bodies are assessed for ecological status and chemical status. Ecological status is assessed for a number of elements, and chemical status is split into 3 subgroups. In contrast, the marine strategy uses 11 descriptors, and these assessments are combined to give us the good environmental status under the marine strategy assessment. 3 of these descriptors, 1, 5, and 6, use similar data and indicators as in the water framework assessments. Indicators 8 and 9 are assessed against environmental quality standards. These environmental quality standards are developed for substances and are hence generally applied across regulations. I will now present the key statistics for transitional and coastal water bodies. 10 of the 25 marine water bodies achieved good ecological status in the assessments in 2018, 2021 and 2024. For chemical subgroup A, 14 more water bodies failed to achieve good chemical status in 2024 in comparison to 2021. This is due to more extensive monitoring, which resulted in widespread exceedances of the HCH pesticide. 2 of these additional failures carried across into subgroup B, which also includes the failures from subgroup A. 4 of the additional failures in subgroup B in 2024 can be attributed to a new substance like cypermethrin called bifenox. In subgroup C, all water bodies failed to achieve good status due to the inclusion of UBPT substances. I'm now moving on to lakes. 5 of the 21 lakes achieved good ecological status in the 2024 assessment. That is slightly up from 2021. The 5 lakes that achieved good ecological status are Castle Hume, Fee, Skolben, Silent Valley, and Spelga. No lake failed in subgroup A for chemistry in 2024 or 2021. There is also no change in chemistry status for subgroup B between 2021 and 2024. In both assessment years, 10 lakes out of the 21 lakes in Northern Ireland failed to achieve good chemical status. Due to the inclusion of UPPT substances in subgroup C, all 21 lakes failed the chemistry status in that subgroup, both in 2021 and 2024. I'm now moving on to rivers. Only 29% of our river water bodies achieved good or better ecological status in 2024. That is a deterioration from 2021, where 31% achieved good or better ecological status. In subgroup A, 4% of our river water bodies failed to achieve good chemical status. That is a slight increase from 2021, where only 3% failed to achieve good chemical status in subgroup A. In subgroup B, which includes the failures from subgroup A, 10% of the river water bodies failed to achieve good chemical status. That is unchanged from 2021. In subgroup C, which builds on the failures from subgroup A and B, 100% of river water bodies failed to achieve good chemical status due to the inclusion and extrapolation of the UBPT substances. I will now give some quick tips on DARA map viewers. There are a number of DARA map viewers, and you will reach this landing page by either clicking this link or scanning the QR code. If you are interested in maps supporting the water statistics report, please select the second map viewer, the NIEA Catchment Data Map Viewer. To navigate the map viewer, please click on this layer icon, which will expand the menu of available layers. You can then click on the little triangles, which expand the layer packages further. If you click on the 3 dots, you will get a menu which allows you to open the attribute table. Please also look out for a further video which explains how to use the map viewer. I would like to finish my presentation today by giving you some ideas how you can contribute to making our water environment better. Our minister has stated that work to improve the water quality of our water bodies will require collective action across government, the public and private sectors, and also wider society. Below are some links that give you ideas on what you can do to protect and improve our water resources. Netrix does not only give advice on environmental compliance to businesses, but also tips to households. Households use a lot of chemicals that can impact on water quality and generate sewage, and we should use as little as possible. The second link leads to the Northern Ireland water page and reminds us that only the 3 P's, pee, poo and paper should be flushed down the toilet. Other items can lead to blockages in the sewer network, potentially causing overspills into the water environment. The third link gives advice on water saving. It is important to remember that saving water also reduces the amount of sewage volumes generated. That reduces the pressures on our sewage network and sewage treatment plants. The pressures on the sewage infrastructure are linked to overspills and development constraints. The last link gives advice on water bots. Using water bots not only reduces the amount of drinking water used in the garden, but also contributes to flood alleviation. Water bots can store water during heavy rainfall event and hence reduce peak flows during these events. That contributes to reducing likely flooding and sewer overflows. Thank you for your attention.